Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best college in entire India. It is the fastest upcoming college in the country. It has a very nice and beautiful looking infrastructure that is situated in lush green surroundings. It offers a variety of courses from ranging from BTech, BBA, BCA, and soon starting up with MBA Architecture and Law. This is one of the finest education providing college. It provides best education in the industry at very affordable prices. It gives 100% placement and job assistance to its student. It is very student centric. It has very nice infrastructure, facilities, faculties. It's very nice college. This is the best career choice that you can make for yourself. The subject we shall be discussing in here is Mathematical Foundations of Computer Science, BCA 108. This is a BCA second semester subject and the syllabus is in accordance to MDU University Rohtak. The topic we shall be looking in this videos are subgraphs, isomorphic and homomorphic graphs. Al Shalini from BCA department shall take you forward. Subgraph. Okay. A subgraph S of a graph G is a graph whose set of vertices and set of edges are all subsets of G. It means the vertex also and the edges also will actually be a subset of the main graph. All the edges and vertices of G might not be present in S. But if a vertex is present in S, it has a corresponding vertex in G, and any edge that connects two vertices in S will also connect the corresponding vertices in G. All of these graphs are subgraphs of the first graph. See, if I look at this figure, so the very first figure and all the that are after are actually all subgraph of the first graph, right? So the vertex also is a subgraph and the edges also are actually a subset of the main graph. Okay, see, now a vertex induced subgraph, like what is a vertex induced? It is one that consists of some of the edges, some of the vertices of the original graph and all the edges that connect those vertex. See, if I have this first one is the main graph, the second two figures are vertex induced subgraphs. How? See, they have these few vertex in them, and whatever edges are joining these vertex, so from the main graph actually are a part of it. So you take few edges, few vertex from the main graph, and then you connect the original edges by which they are connected, right? That is the edges that they share among themselves. So that becomes a vertex induced subgraph. Similarly, we have an edge induced subgraph. In this, some of the edges are considered and the whatever endpoints corresponding to that edges are taken, right? So edges are taken and whatever endpoints are joining them, or the vertex that lies on the two endpoints are taken, right? So the second two graphs are actually a edge induced graph of the first one. Okay. Okay, why it is not a vertex induced graph? See, because I have taken this four main, but I have not taken the edge in between, the diagonal edge in between them. So now think you are clear of what a vertex induced subgraph and a edge induced subgraph, right? So here the vertex, if you take, then you have to take the edges between them. Or you missed the diagonal over here, so it cannot be said to be a vertex induced graph, wherein if edge induced, if I take the edges, then I'll take the endpoint vertex also, right? So it's an edge induced graph, subgraph. Okay, now here in this figure, this is actually a subgraph of the first, but this is nor edge induced and nor this is a vertex induced. See, we have taken a vertex, but we have not taken the edges between them, so definitely it is not vertex induced, and it is also not edge induced, because you have taken whatever that you are taking an edge, but you have this extra kind of endpoint is there, like this vertex, so it is not an edge induced subgraph, right? because if you had to take this edge at least, or this, but you have not taken the other endpoint, just single one that you have taken in. Okay, so there's something extra that for you can note it down, but that's not in your syllabus. Like a spanning subgraph is a subgraph that contains all the vertex of the original graph. So any subgraph that will have all the vertex of the original, all the vertices from the original, will be a spanning subgraph. A spanning tree is a spanning subgraph that is often of interest. A cycle in a graph contains all the vertex of the graph to would be called a spanning cycle. So if it would form a cycle along with the spanning subgraph, it would form a spanning cycle, or you call it a Hamiltonian cycle, wherein you will consider all the vertex, and the cycle, if it is forming, then it becomes a Hamiltonian cycle, right, or a spanning cycle. Okay, next is isomorphic graph. Okay, now what is isomorphism? See, an isomorphism exists between two graphs G and Z if the number of vertex in G and the number of vertex in H are equal, right? And if the number of edges are also unequal. So you have to note down here that 2 points do not guarantee isomorphism. So you have to look at other things also. So in addition, if a function f is obtained from a relationship between the vertices of G and the vertex of H, then f should be 1 to 1 and on to bijunction, and the number of vertex with same degree must be same in G and H, right? So a degree is a number of edges connected to a vertex. So whatever the number of degrees is there in G that you are taking in the first graph, so similarly the same number of degree has to be in the second graph H, right? So in simple words, and isomorphism from a simple graph G to a simple graph H is bijunction function if v of G is implying giving v of H such that the uv wherein the edge uv belongs to the G graph, and the set of edges from the G graph, and wherein the v is belonging to the H graph, right? So in that case, so you edge the map, like you can do a one-to-one mapping if you are seeing, or you can do an on-to mapping, right? So the way you are doing, so you if you are seeing u in the one, then you see the other kind of corresponding which vertex you are seeing or which edge you are seeing, right? So vertex corresponding to vertex and edge corresponding to an edge, right? This is how you see it. See, so in this example we can take the number of edges. You see that number of edges must be same, number of vertex must be same, and their connectivity must be retained. So number of vertex with same degree must be in G and H, right? So if I enlarge this figure a bit, so you can see in here this G1, G2, G3. Now this everyone has C degree like 2 2 2, but this W has a degree 3, so this is definitely not a kind of an isomorphism. It is not showing. So G3 is not in any way it's an isomorphism because it has a degree that is more than that. So this is sure no. I think G1 and G2 are there, and the G3 is not there. So this you get. So you have corresponding edges also 1 2 3 4 5 1 2 3 4 5. So you have this, and you see this is isomorphism of this G1 and G2. Okay, now what is an homomorphic graph? See, G1 and G2 are said to be homomorphic if each of the graph can be obtained from the same graph by dividing some edges of G with more vertex, right? So what you have a number of edges, you are just increasing the vertex on that edges, right? So see, you have this PQRS, so this is graph, and in this graph then you became the first graph you obtain a second graph by putting PQ. Okay, if I don't consider T, this is PQSR, right? So this is how it is forming, and if I put a T dot in between, like on the RS edge, right? So then it becomes homomorphic to the first one. Okay, then okay, now these two are also homomorphic to the first one. See, PQ was there. See, look at this here. PQ was there. Then there's this RT. So you have this RT, right? You have this TS. So you obtain this TS from there, and you have PQ. So you have a PQ. So now you look. PQ was there, RS was there. So this RS was a direct kind of an edge, and you divided this RS kind of a direct edge by putting a T. Similarly here also, this is how it is doing, like P2S and S2T, it is being divided. S2Q is there, and you have S2T is there, and you have P2Q and you have P2S. So G, okay, there's this thing to be noted down also, that if G1 is isomorphic to G2, then G1 is also homomorphic to G2, right? So whatever you have to look at that if two graphs are isomorphic, they have to be homomorphic also. But the converse need to be true. Like if it is homomorphic, it may not be isomorphic. So this is there. So we are done, and here the important question are: what is a subgraph, what are isomorphic graphs, and what are homomorphic graphs? So I hope it is clear. I try to keep it very simple. Hope you like the video. Thank you. Take care.